So let's take a quick look at a simple circuit here again. Here we have our battery with our positive and negative end. Okay. And then we have our circuit, and we're going to put a resistor up here, which we have that symbol with the kind of squiggly line there as a resistor. And so as current flows from our positive to negative, it's going to go through this thing called a resistor. Now what a resistor is doing is it's sort of dissipating electrical energy, usually in the form of heat. So it's just kind of giving off a little bit of heat to change the current and the voltage within this circuit. And so what we want to look at today is that relationship between current, voltage, and resistance and how that works together in a very simple circuit. So to think about what resistance is and what happens inside a resistor and even inside a wire, okay, let's kind of take a look inside our wire here. And if we have electrons moving through our wire, okay, let's say they're all moving in this direction. What's going to happen is as these electrons try and move through the wire, they're going to occasionally bump into each other. They're going to bump into, the sides of the wire. They're going to bump into each other as they move. They're all negatively charged particles, so they're going to, push against each other. So if they get too close to this one as it moves forward, it might push it back a little. So there's all kinds of things that can happen in here. And so resistance, in a way, is kind of like friction within the wire. It's friction on those electrons, not allowing them to move just easily and freely through it. And so certain materials have certain higher resistances than others, and those would be the ones that we actually use for resistors in a circuit. And because, much like friction will generate heat, this sort of activity will generate heat as well within a wire or within a current in a resistor. And so that'll dissipate some of the energy that's within that circuit. Voltage, right? A lot of times when we think about volts, we think about a battery. So let's just kind of think about this for a second. Okay, it goes off to whatever on either end, but we have our battery, and let's say it's a 9-volt battery. Okay, what that means is there's what we call a potential difference of 9 volts from one end of the battery to the other. And you can think of this as being like a potential energy, in the sense that this is going to have 9 more units of potential energy on my plus side than on the positive side. So as it goes through the circuit, it goes from having a high potential energy of 9 volts on this side to, or 9 units on this side, let's say, to 0 units on this side. So there's what we call a potential difference of 9 volts from one end of the battery to the other. And the bigger that number, the bigger that difference, the more we can push through here, the more energy we have to push things through our circuit. So this leads us to Ohm's law, which is kind of the relationship between voltage, resistance, and current. And what Ohm's law tells us is that current is equal to voltage over resistance. So that's how we can calculate, say, how much resistance is in a wire, or how much current, or how much voltage, given that we know the other two values. So Ohm's law is current equals voltage over resistance. Unit-wise, right, we have amps for current, and we have voltage, or volts, and then resistance is measured in ohms, which we use the Greek letter omega for. So let's take our example before where we had a 9-volt battery. Let's say, so we have 9 volts. Let's say we have a 3 ohm resistor attached to that circuit. Then that means the current flowing through it, the number of coulombs per second, remember, would be 3 amps. So that'd be kind of a very simple example of Ohm's law. The circuit, right, that would go along with that would look something like this, right? We'd have our battery at one end that was 9 volts, and then going around it, we'd have our resistor up here, and that resistor would be a 3 ohm resistor. And so if we measured the current that was flowing through this circuit, we would get a 3 amp current.